This video is going to cover writing and solving linear equations just from a basic word problem format. So let's start with our first example. Martin owns a farm where he makes hay bales every year. In his first year, he sold 42 hay bales. In his second year, he sold 50 hay bales. If his sales growth continues at the same rate each year, create an equation that models the number of hay bales sold, we'll call that Y, based on the number of years he has been selling hay bales, X. So typically, whenever you see these type of problems, time, in this case, the number of years, is going to be your X value, and then Y is going to be whatever depends on the number of years that goes by. So X years would be your independent variable, and then your Y would be your dependent variable. So I'm going to go back and highlight some important things. In his first year, so year one, he sold 42 hay bales. In his second year, he sold 50 hay bales. So with that information, we can actually construct a table to figure out what the slope of this linear equation would be. So we can have an X and a Y in our T-chart here. In his first year, he sold 42 bales, and in his second year, he sold 50 bales. So to find your slope, which is also labeled as your change in Y over change in X, or some people say delta Y over delta X, you figure out the difference between the numbers in your table. So from 1 to 2, we had to have gone up by 1, and from 42 to 50, we went up by 8. And keep in mind, you want to put your change in Y values, so that's 42 to 50, the plus 8. You want to put that on top of your change in X values. So that would be a positive 1. So our slope here, or our delta Y over delta X, is 8 over 1, or you can just say 8 if you'd like. Now we're going to use one of the points in our table to construct the equation. I'm going to put it in point slope form. And this may not look like the point slope form everyone is used to, but this is the point slope form that we use at my school. So I'm going to do it the way we do it at my school because I think it lends to future learning. I'm going to start by selecting one of my 2 points. It doesn't matter which one you use. So I'll do 1 and 42. And I'll say y equals, my slope is 8. And then I'm going to say x in parentheses, and then the opposite of my point. So the x value in my point was 1. I'm going to say the opposite of that is negative 1. So x minus 1 and then plus 42. Some people are used to seeing point slope form like this. And if your teacher or your school requires that, just go ahead and move the 42 over by subtracting 42 on both sides. And then you'll get it in like traditional point slope form. But we use this point slope form that looks like this, where we have the opposite of the x value inside of our parentheses and then the y value outside of our parentheses. So we're going to say y equals the slope, which is 8, x minus your x value from your table was 1, plus your y value from table, which was 42. So based on this model, we're going to predict how many bales Martin will sell during his 4th year selling hay bales. So 4th year, remember, x is our time. So we're going to be plugging in 4 for x because x represents the number of years that have gone by. So we'll say y equals 8 times 4 minus 1 plus 42. And then we're just going to solve this using order of operations. So we're going to first start by looking inside of my parentheses. Inside of my parentheses, I'm going to do 4 minus 1. And 4 minus 1 is just 3. And I'm going to bring everything else down around it. Now I'm going to do multiplication. 8 times 3 is 8, 16, 24. So we'll say 24 plus 42. And then all we have left is this addition. We're going to do 24 plus 42. And that is going to give me 66. So I predict in his 4th year, he will sell 66 bales of hay. Okay, so that is just a basic linear word problem. We're going to do a couple similar ones. I have a total of 4 examples. They're going to be the exact same process. So we are going to write them in point slope form like this, and then we're going to solve for a y value by plugging in a value for x. Let's try this again. Jasmine runs a small bakery. In her first week, she sold 36 cakes. So we're going first week, 36 cakes. In her second week, she sold 44 cakes. If her sales growth continues at the same rate each year, let's change that to week. Sorry, my bad. Each week, create a equation that models the number of cakes sold based on the number of weeks she's been selling cakes. So we're going to say we have an X and a Y. So we'll have our first week, she had 36 cakes. And then the second week, she had 44 cakes. And sorry about that typo where I wrote year. Clearly, I recycled this from the previous problem. Let's go ahead and find our change in Y over our change in X. So from 36 to 44 was plus 8, and from 1 to 2 was plus 1. So our delta Y over delta X is again going to be 8 over 1. So we'll say Y equals 8, which is our slope. I'm going to use the second point now. So it doesn't matter which one you use. I'll go ahead and use the second one. So I'll say X minus my X value, which is 2, plus my Y value, which is 44. So that's my equation. This is my slope. This is the opposite of the 2 from my table. And then this is the Y value from my table. Now I'm going to predict how many cakes she'll sell in her 5th week in business. So remember, time is your X. So I'm going to plug in 5 for my X value. And then I'm going to do what's inside of my parentheses first. So inside of my parentheses, 5 minus 2 is 3. And I'm going to have 8 times 3 again. 8, 16, 24. And 24 plus 44 is going to give me 68. So I predict she'll sell 68 cakes at the end of her 5th week. All right, we have 2 more examples. Let's go ahead and do them. Carlos tutors his peers in Algebra 1. The first month he started tutoring, he had 28 students. So we can actually just go ahead and put that right in our table. We know what it's going to look like. First month he had tutoring, he had 28 students. The second month, he had 35 students. Assuming the number of students who attend tutoring increased at the same rate each month, create an equation that models the number of students tutored. So Y is our number of students tutored based on the months that Carlo has been tutoring, X. So we'll do our change in Y. This is our change in Y. From 28 to 35 is plus 7. And then our change in X is just plus 1. So our change in Y over change in X, which is our slope, is going to be 7 over 1, which is just 7. To put this in equation, you just pick one of the points. Let's go ahead and just pick the top one. Again, it does not matter which one you use in a linear equation. We'll say Y equals our slope, which is 7, times X minus the X value from your table, so minus 1, plus the Y value from my table, so plus 28. Okay, and then based on this model, we're going to predict how many students Carlos will have at the end of a 10-month school year. So we're going by months. So we're going to plug in 10 for the X value, for the number of months. We'll say Y equals 7 times 10 minus 1 plus 28. So we'll say Y equals 7. We're going to do what's inside of the parentheses first. And inside of the parentheses is 10 minus 1. 10 minus 1 is 9. So we'll say 7 times 9 plus 28. Next, we'll do our multiplication. We're going to do 7 times 9, which is 63. And bring down our plus 28. And 63 plus 28 is going to give me 91. So I predict that he is going to have 91 students at the end of the 10-month school year. Okay, we have one more example we're going to do. Let's go ahead and knock it out. Ava starts dog walking to help save money for her own apartment when she graduates from high school. Her first year that she was walking dogs, so first year, she walked 60 dogs, and we're going to call this her freshman year. Her second year, so that's her sophomore year, she walked 68 dogs. Assuming the number of Ava's dog walking clients grows at the same rate in the coming years, create an equation that models the number of dogs walked, which is your Y, based on the number of years she's been walking dogs. So we're going to say X and Y. Remember, X is your time. So we're going to say the first year she walked 60 dogs, and the second year she walked 68 dogs. So my change in Y is going to be plus 8, and my change in X is going to be plus 1. So when I do my delta Y over delta X, I'm going to have a 8 over a 1, which is just 8. And then let's go ahead and make the equation. So I'll use the point 268. We'll say Y equals my delta Y over delta X, which is 8. and then x minus the x value from my table, which is 2, plus 68, which is the y value from my table. Based on this model, predict how many dogs Ava will walk for her 4th year of high school. So this is going to be her senior year. We'll say y equals 8. We're plugging in 4 for x because x is the number of years she's been walking dogs. And then we'll do our parentheses first. So I'm going to do 4 minus 2, and 4 minus 2 is obviously 2. And then bring down your 8 and your 68. 8 times 2 is 16. So we're doing our multiplication next because I'm following order of operations. And then we have 16 plus 68. 16 plus 68 is going to give me 84. So I predict at her senior year of high school, she will walk 84 dogs. She'll have 84 dog walking clients. All right, that's it for our